Now, coming to the chemical bonding chapter. So, in the chemical bonding chapter, what you find is that I've already said you about that why do atoms undergo bond formation, how do they undergo bond formation, the different type of bond formation, that is electrovalent bond, covalent bond, I've discussed with you. But still I feel that some more points I need to add it to it. Alright, like there is a term which is called as electrovalency. Write it down, children. Electrovalency. Right. Okay, what is electrovalency? The number of electrons lost or gained. The number of electrons lost or gained. What I said? Electrovalency. The number of electrons lost or gained during the formation of an electrovalent linkage. During the formation of an electrovalent linkage is termed as electrovalency of the element. Is termed as electrovalency of the element. We can say that. Now, next is coordination number. Another definition. Coordination number. Generally, you will see it is noted the letter Cn, C dot N dot. So, what is coordination number? Write the definition. Coordination number of an ion. Coordination number of an ion may be defined as the number of. Oppositely charged ions. Number of oppositely charged ions present as the nearest neighbor around that ion in an ionic crystal. Around that ion in an ionic crystal. Okay, now let me explain you these two things. First is electrovalency. See, when an electrovalent bond is formed, how it is being formed? By the transfer of electrons from an atom which is having excess of electron to an atom which is having deficiency of electrons. So, number of electrons which is being transferred, that is lost or gained. Alright, number of electrons which is being lost or gained during the formation or due to the formation of electrovalent bond or electrovalent linkage or ionic bond, it's also called ionic bond, is known as electrovalency. Suppose one electron is lost. Alright, one atom is losing an electron. So, what is electrovalency? 1. Suppose like calcium, it will lose 2 electrons because calcium has got 2 electrons in the outermost shell. So, electrovalency is 2. Alright, like calcium combines with oxygen. Oxygen is gaining a pair of electrons, 2 electrons. So, what is the electrovalency? Again 2. But here if it is chlorine, so 2 chlorine is gaining an electron, isn't it? Each chlorine gains an electron. So, for each chlorine, the electrovalency is 1. But if you say what is electrovalency for the negative radical, it is nothing but again 2, because negative radical is chlorine. So, how many is there chlorine? 2 chlorine, so it is 2. But for each chlorine, listen carefully, for each chlorine, it is gaining 1 electron. So, hence electrovalency is 1 in this way. Alright, I hope you understood. Now, next is coordination number. Coordination number means, suppose around a particular ion, how many ions are attached or how many ions are surrounding that particular ion, that is called as a coordination number. That is the number of nearest neighbor attached to it. Alright, the number of nearest neighbor which is attached to it is called as coordination number. So, coordination number of an ion, because I am talking about ionic bond, so hence I am saying ion. Alright, of an ion is defined as the number of oppositely charged ions. Alright, present as a nearest neighbor. For example, suppose we are having a sodium ion. Alright, so around sodium ion, how many, that is oppositely charged ions are being present? Suppose if it is sodium chloride, so how many oppositely charged ions will be there? Only 1 chloride, Cl minus. Alright, of course it will not be in contact, it is not a covalent bond, it will be near to it. Alright, Cl minus. So hence the coordination number is what? It is 1. We can say that. For example, if you take aluminium, Al3+. So you know what is the formula of aluminium chloride? AlCl3. So how many chloride ion will be there? 1. Then here 1, 2, here 1, that is 3. That's it. So this is called coordination number. So coordination number is here 3, here the coordination number is 1. Alright. Clear? So in this way, it depends that suppose we are having a particular ion and how many ions are surrounding that particular ion. Oppositely charged. It has to be. Because same charges, if it will come means it is going to repel. Oppositely charged one only will come near to it, so that it is going to get attracted. So hence, when oppositely charged ions are surrounding a particular ion, then it is known as what? It is nothing but known as a coordination number of that particular ion. Clear? Fine. I think you understood this particular fact. What is coordination number? Now next is C, that is formation of ionic bond. Of course, you have understood. Once more, just let me tell you. For the formation of ionic bond, the one of the factor is that one of the atoms should have low ionization energy. Why? Because if it is having low ionization energy, it will readily lose an electron to form a cation. So cation is being formed. Alright, a cation is being formed easily. A cation is being formed. Now the second factor is the second atom, alright, because one of the atoms should have low ionization energy. The second atom should have high electron affinity. If it is having high electron affinity, then it will readily form an anion. Because electron affinity is what? Or electron gain enthalpy is what? I have already said it. That is, it is nothing but the amount of energy released when one electron is added to the outermost shell or one electron is gained to the outermost shell of an isolated gaseous atom. So if it is having high electron affinity, it is readily going to form an anion. And if it is having low ionization energy, it will readily form a cation. Do you think cation anion is formed and ionic bond formation is going to take place? No. Alright, first it forms a cation. Done. Then it forms an anion. Done. Then when the cation and anion will come closer to each other, a force would exist between them. And that force will result in the formation of ionic bond. And hence the ionic bond has to be stable. So when the cation and anion they come closer to each other, what happens? Some force results in between them and energy is released. Alright, energy is released because always remember, energy is inversely proportional to stability. So more the amount of energy released, less energy will be present in the given compound. And if energy present is less, this is less, because this value is less, then the stability will be more. Alright, because if this is less, this is inversely proportional to stability. If this is less, this has to be more. So stability will be more, we can say that. Clear? Or we can say stability is inversely proportional to energy. Anything, you can say that. Clear? So in this way, what we find is that when a cation and anion they come closer to each other. For example, let us say sodium ion and chloride ion. They come closer to each other. Do you think they will form a, what you can say, ionic bond sodium chloride readily? No. When they will come closer to each other, definitely an electrostatic force of attraction results in between them because they are of opposite charges. So due to that electrostatic force of attraction which results between the two oppositely charged ions, some amount of energy is released. And that energy is otherwise known as what? That is called as lattice energy. Because lattice means what? Definite geometrical structure. And you know, ionic compounds are basically solids and they have got definite geometrical structures. Alright, so what I said, the amount of energy released. So what is the definition of lattice energy? The energy released when 1 mole of ionic compound is formed from its respective ions. Alright, the amount of energy which is released for the formation of 1 mole of an ionic compound from its ions. Alright, so when positive and negative ion they come closer to each other, alright, 1 mole of course, alright. So hence the amount of energy which is released, alright, that energy is called as lattice energy. And remember that higher is the lattice energy, more stable is the compound. Because what I said, the energy which is released, if it is more and more, so the less amount of energy will be present in the compound. And if a compound has got less energy, then the stability will be more. Alright, so when a cation and anion they come closer to each other, then what you find is that, again I repeat, electrostatic force of attraction results in between them. So due to this electrostatic forces of attraction which results between them, energy is released. And that energy which is released, alright, that is called as lattice energy. Lattice understood, definite geometrical structure. Alright, so in this way, what you find is that more the amount of energy is released, more stable is the compound. So lattice energy should be as high as possible. So hence I say lattice energy is directly proportional to stability. Otherwise energy is inversely proportional to stability. But lattice energy is directly proportional because more the amount of energy released, more stable is the compound. Alright, interesting. Now this lattice energy depends upon certain factors. It depends upon the charge of the ions. See, when the charge is higher, the size of the molecule, the size of the ion will be smaller. Alright, for example, that is, if you are having Na plus ion, and if you are having Ca2 plus ion, and if you are having Al3 plus ion, which is the smallest? This one is the smallest. This one is the smallest. I have told you about it. Alright, if you calculate the Z by E, because these three are isoelectronic species. It has got 13 electrons, so after losing 3 it is 10. It has got what you can say Mg2 plus here, sorry, okay, instead of Ca2 plus it should be Mg2 plus. So what you find is that this also has got 12 electrons, after losing 2 electrons it is 10. Then 11, sodium atomic number is 11, after losing 1 electron it is 10. So these three are isoelectronic species, we can say that. Clear? So the smaller is the value of Z by E, larger is the size of the ion. So if it is isoelectronic species, so Z is how much here? This is 11, this is 12 and this is 13. And E is how much here? 10, 10 and 10. I need to find Z by E. So it is 11 by 10, so it is 1.1. It is 12 by 10, so it is 1.2. It is 13 by 10, so it is nothing but 1.3. So what I said, smaller is the value of Z by E, larger is the size of the ion. So this is smaller. So sodium ion is bigger compared to magnesium and aluminum. So I said it. So smaller, this particular ion is the smallest. So if it will be smallest, what it says, now see here, when the ion will be smallest, the bond length will also be smaller. Alright, the bond length also will be smaller because size of the ion is small. So the bond length between the positively charged ion and negative charged ion will also be smaller. So when the bond length is small, it is be a strong bond. For example, see, this is a bond length. Let us say this is a bond length, and this is a bond length. Which is easy to break for you? Which is easy to break? Definitely, this is the bond which is easy to break. I can break it very easily because larger is the bond, less stable is the bond, because weaker is the bond. The bond length increases, it becomes more and more weak. Smaller is the bond, see, smaller is the bond, difficult. Is it easy for you to break? No, it is not easy, it is difficult. So hence, for that purpose, remember it always. Smaller is the bond, stronger is the bond. See, this is smaller, this is stronger. And larger is the bond, weaker is the bond, because I can easily break it this one. Alright. So here also, aluminium charge is, what you can say, maximum. So size is smaller. So bond length is also smaller. So it forms a strong bond. Alright. So hence, what you find is that if the bond is stronger, definitely more amount of energy has to be released. Alright, so if it is forming sodium chloride, magnesium chloride, aluminum chloride, in which case it will be more stable and more energy will be released in case of aluminum chloride. In case of aluminum chloride compared to magnesium chloride compared to sodium chloride, because aluminum chloride, the size of the atom is smaller, the size of the ion is smaller, the bond length is smaller. Alright, so definitely to form a stronger compound, to form a stable compound, more amount of energy has to be released. For that reason I said lattice energy also depends upon here, that is on the charge of the ion. So smaller is the, what you can say, higher is the charge on the ions, smaller is the size of the ion. And smaller is the size of the ion, stronger is the bond formed. And stronger is the bond formed, more amount of energy is released. And more the energy is released, less the energy is present in the compound. And less the energy is present in the compound, more stable the compound it is. Because already I have said you, energy is inversely proportional to stability. Alright, I hope you understood. Next is the size of the ions, which also I have discussed with you. Alright, here you can see the size of the ion is smaller. So definitely this is much more a stronger one. Now the net effect is that if you see lattice energy and if you take electron gain enthalpy, then it should be greater than ionization energy. Alright, what I say, I have given in my what you can say in the paper, lattice energy plus, that is electron affinity or electron gain enthalpy, if it is greater than ionization energy, then it will result in the formation of a stable compound. The net effect is that a large amount of energy will be released and the ionic bond is being formed, and that is also a stable bond. We can say that. Alright, clear? If lattice energy plus electron gain enthalpy or electron affinity, if you add it, and if this value is greater than ionization energy, as I have written it here, then the net result is that a large amount of energy is released. And I said you just now to you, if energy released will be more, then energy present in the compound will be less, and hence the compound will be more stable in nature. So that ionic compound will be stable in nature, so to say. Alright, fine. So in this way, we came to know about, what you can say, some of the factors of electrovalent bond which I thought that I should discuss with you. Alright, and if you see the properties of the electrovalent compound, they are basically solid, they are crystalline in nature because they have got a definite geometrical structure. They have high melting and boiling point because they have got strong electrostatic force of attraction between them. Due to this reason, to separate the ions, a large amount of energy is released. So hence they have got high melting and boiling points basically. Now they are soluble. Generally these compounds are soluble in polar solvent, for example water. Because when they are put into water, they dissociate into its ions and hence they are soluble in water. Alright, so ionic compounds are basically soluble in polar solvent, and you must be knowing it, you have read in the lower classes that water has got high dielectric constant. The only liquid which has got high dielectric constant is water. For that reason we say that water is a universal solvent, because large amount of substances, alright, large variety of substances, not amount of substance I should say, large variety of substances dissolves in water. Different substances that dissolves in water, because water due to its high dielectric constant, it dissociates. Alright, if it's an ionic compound, it will dissociate into its ions, and due to this reason it will be soluble. Alright, due to this reason it will be soluble, we can say that. Clear? And one more thing you must remember here, always remember here, that if a compound is soluble, when a compound is dissolved in water, again energy is released. That is called as hydration energy or hydration enthalpy. Alright, if the hydration enthalpy is more than the lattice enthalpy, listen carefully, you may write it down. If the hydration energy or hydration enthalpy is greater than lattice enthalpy or a lattice energy, then the compound is being soluble in water. That means what? When a compound is put into water, when an ionic compound is put into water, it dissociates into its ions, due to which energy is released. The more the amount of energy released, same thing, the compound is more stable. So hence here also, when you put a compound into water, when you are putting an ionic compound into water, the energy is released, which is called as hydration energy. So if the hydration energy is greater than the lattice energy, then the compound will be soluble in water. If the hydration energy is less than the lattice energy, the compound will be insoluble in water. For example, lithium chloride, even if it is an ionic compound, it is not soluble in water. It is not soluble in water, it is an exception, because you know chemistry full of exceptions are there in chemistry. So lithium chloride, it's an ionic compound. It is being formed with the transfer of ions, but still then it is not soluble in water. Why? Because when lithium chloride is put into water or lithium oxide is put into water, the hydration energy is less than the lattice energy. The energy which is released is less than the lattice energy. Lattice energy, you understood? The energy which is released for the formation of 1 mole of ionic compound. So it is less than the lattice energy, hydration energy, due to which it is not soluble. And if it is just equal, then it is just slightly soluble in water. Means lattice energy is equal to hydration energy, just we can say that, and it is slightly soluble in water. Alright, clear? In this way, you have to remember this thing. If hydration energy is greater than lattice energy, the compound is soluble. If hydration energy is less than lattice energy, it is insoluble, even if it is an ionic compound. Example, lithium oxide, lithium chloride. And if hydration energy is equal to lattice energy, then it will be just little bit soluble, we can say that. Slightly soluble, we can say that. Clear? For example, sodium chloride. Clear? We can say that. Clear? So in this way, in case of sodium chloride, where did I say that? You will say the sodium chloride is highly soluble in water. Yeah, done. I know that. But if you increase the temperature, the solubility does not increase. The graph remains almost a straight line. It is not like potassium nitrate and ammonium chloride, the graph goes up with increasing temperature. It's a steep graph. No. For that reason I said that. Otherwise at room temperature, sodium chloride is highly soluble in water. No doubt about it. But with the increase in temperature, solubility hardly increases. That is what I speak to you. Now, next is electrical conductivity. You find that ionic compounds are poor conductor of electricity in the solid state. Because in the solid state, they do not have free ions. They do not have free ions. Free ions I am saying you. Don't say they do not have ions. Ions are there. But the ions are held together by strong electrostatic forces. They do not have free ions, and due to the absence of free ions, they do not conduct electricity. But in the aqueous solution state or in the molten state, they do conduct electricity, because they have got free ions. Alright? And ionic compounds, they show the ionic reactions. Okay? So all these are the properties, we can say that, of ionic compounds or electrovalent compound. Okay? Fine.